So the question either says find the D, which is the pipe size, or again, if you notice, you have discharge. This is not the second category. You have HA and HB, which is the difference between these two, which is your head losses. So head losses is not questioned. Discharge is not questioned. So you need to find the pipe size. Again, I will start to write the Bernoulli or energy one more time. HA minus HB equal to all losses, and you have HA, you have HB, so it's 100 meter. And again, HL equal to HF plus H of exit, H of entrance, which you have F L over D, K of entrance, K of exit, and V square over 2G. The problem again starts here. Why? If you look, I have this guy. I don't have it, don't have it, don't have it. And when I say I don't have it, it means that I cannot even calculate them because F related to Reynolds and this guy, which D is here, D is here. And for velocity, I need to write this equation. D is here. So everywhere I start to solve it, I need this, the diameter, and I don't have it. So F is not going to be calculated. D is not going to be calculated. V, F, all. So again, I need to make an assumption. The assumption here is, let me show it here maybe. Here is the one. If your L over D is a large number, like you have a pretty good amount of length and the diameter is not very big, so you can ignore the minors. That's the assumption that you need to make. So I will say that assumption here for me is L over D is pretty large, so I will neglect all the minor losses. And if I do that, I will rewrite this guy here. HL equal to F L over D. I'm going to make it 0, multiple by velocity square over 2G. Meanwhile, I would like to write V like this guy, whatever I have, I E square over 4, which gives me what's the velocity here? If you make it simplify, you will end up this guy. Replace velocity. If I replace velocity, I have 100 for HL. Still, I don't have F. Still, I have L. I don't have D. Instead of velocity, I will write 0.23 divided by E square. The whole thing is square over 2 multiplied by 9.81. A bit better. That's the one. And if I simplify that, I would like you to have one equation including F and D. And you need to keep this guy. I will call it a star because you need it later. The assumption neglects all the case. I don't know if the length is not high enough, what would be the solution? But in this case, just consider that we are going to neglect all minors. And if we write that once here, once velocity, you will end up one equation which has D and F. Keep it. The assumption starts here. I want to find D. I have no idea. So let's start with the first assumption. I will start with 0.5. Actually, you know the correct answer, right? Because previously you have the diameter. It was 30 centimeter. But consider that you don't know it. So you are going to make like some random assumption. I'm going to consider it like 50 centimeter. So find E over D and Reynolds. E over D is the same. No, okay, sorry, no, not the same because D is different. Do you remember we have this guy, but millimeter, don't forget it. And we have this one in meter. So I'm going to multiply it by 1000 to make it consistent. So 0.0003. Reynolds V D over nu. Nu, you have it. D, you just consider it. And instead of velocity, what would I put? I think I made the velocity here. 0.523 divided by E sky. The one that you made it. So if you do that, you will have these ones. So I want to read F from here. I just assumed it. And now I'm going to find my F. Make sure that I'm in a correct way. So keep in your mind these two numbers. Do I have here? E over D was 0.0003. Reynolds was 1.0.5 multiplied by this guy. E over D here, right? Yeah. Reynolds is 1. That's the one. I think I considered 1 because it's close to 1. So this guy, something like that. So if I find this one, it means that I'm a bit above, sorry, it should be somewhere here. I'm a bit above this number, 0.0155, or I will say that it's 16 to make it easier. Here we go. 0.016 is my number. Now you need it to be checked. How? Use the star. Do you remember the star? Oh, here, the star one. It says that whatever you are doing, you should fulfill this one. Not 4, 5. So F is this number. If I do that, what's your discharge? Sorry, not discharge, diameter. Diameter? Zero point. .3. 298, which is 3. That's correct. So the one that I assume is not the one that I ended up. So second assumption. Assume D is 0.3 meter. And we know that it's the correct one because we already know that what our diameter is. So if I do that, let me write it here. Second, assume D is 0.3 meter. E over D, I will calculate that one. Reynolds, I will calculate that one. And if I do that, F this time is going to be this number. So replace in the star, what was the star? 7.17 equal to F over D power to 5. F equal to 0.017. We will end up D around, yes, which is the correct answer. So